Hello! Today we are going to show you some prototype of the discrete math learning system based on the OSTIS technology. Some words about changes which were made since our last meeting. Several chapters from discrete math lectures were added to the system along with some exercises for them. Many commands were changed to be more user-friendly as we wished. System functionality extended with several operations in sphere of discrete math, like union, intersection, and so on. And system is now able to solve some problems using user-provided constructions. Let's proceed to system. As I told, we have taken your materials and divided them into chapters. Let's see what chapters do we have there. Just right now we have 4 chapters and several paragraphs. Each of them contains a hypertext and a part of formal text. Let's start reading. As I told, each chapter contains hypertext which can be read just the usual text, but we can ask different questions to selected elements. Let's try to do that. An argument will be the set concept, and the student wants to know which kind of sets does system know. As we can see, set can be subdivided to finite set and infinite set, and infinite set can be subdivided to be uncountable set and countable set. Let's proceed with reading. Each of these paragraphs contains material from your lectures, so we are not going to waste time and read all of them. Let's discuss only several. This paragraph is devoted to the concept of sets, and let's try to ask a question with 2 arguments. The first one will be set, and the second one will be set of sets. The question will be how does these objects link it with each other. System can answer that concept sets of sets is included in the set concept. So you can see it's not so trivial. Let's proceed with reading. Each chapter contains different exercises. For example, the first chapter contains exercise in which we should give an example of a set and define to which type of sets it belongs to. We can do it by ourselves, or we can ask system to do that. The next exercise wants us to select the correct statements. Here we can see all of them. Now let's try to read the second chapter. It is devoted to the binary relations defined on the set. As you know, there are set equality, subset, and so on. For example, if student is too lazy, he can ask a question which relations are defined for the set concept. And as you can see, there are a lot of relations defined on the set concept which system knows. This chapter contains some exercises too. Let's discuss one of them. System wants us to create 2 sets and find relations between them. Let's try to do that by ourselves. We should switch to graph mode and create two sets. The first set will have identifier S1 and the second one S2. And now let's ask a question. We wanna know how the sets are related to each other. System can answer that one of them is a subset of another. Let's look in graph mode. Here is the same information. Set 2 is included in set number 1. Let's shortly consider section number 4. It is devoted to different proofs on the base of a set identities. We merged different materials in one hypertext, so as you can see, it's clear for reading. We can use different formatting methods like bold, cursive and so on. From this section we can go directly back to set operations chapter. Here we are not going to read everything about operations. Let's try to do some exercises. The first exercise wants us to create two sets and find their intersection and union. Let's create our own sets. Let's make identifiers for all elements. That will be A set, B set, and their elements. A, B, and so on. So we have two sets. Set A contains A, B, C elements, and set B contains C and D elements. So you can see that intersection will contain only one element C, and the union will contain 4 these elements. Let's try to check that. Set A is the first argument, and set B is the second. Let's try to find the intersection. The answer is C. In graph mode, that looks like that. The first set, the second set, and the result, which contain only one element C. Let's try to find union. Sequence doesn't matter. And the union contains all 4 elements. first set, second set, result, and its elements. Some short conclusions. So, user can read hypertext as usual text, navigate knowledge base as he wishes, ask different questions including non-trivial, and even solve different tasks. And the user can ask system to solve different exercises with user provided data. As we've seen, we can create our own sets and ask different questions about them. In several days we are going to create a website which will contain that prototype, so you will be able to try it by yourself. We will be glad to answer all your questions. Looking forward for your visit. Goodbye.